So my name is Brad. My name is Brad. I'm the lead product manager with developer tools at Red Hat. Um, that's my dog, not my child. I was testing out the little thing when I had my first kid, and my wife asked me to put that there because she thinks it's hilarious. So I'm a product manager at Red Hat, working in developer tools. So I lead up the OpenShift Developer Sandbox we'll be talking about today, and our new work on Backstage, which if you want to talk about that, we can talk afterwards. So I'm a developer by schooling. So I went to school to be a developer. I actually used to work at Pendo here as an engineer, and I worked in robotics before that. And Vim is the correct answer. Nano is acceptable. Emacs is not. And I'm really passionate about enabling developers to do their best work, enabling them to be as successful as possible with any of their technologies. And so today, Developer Sandbox is really just about that. Now, first thing I want to say is, why did Red Hat choose to invest in building this thing called Developer Sandbox, which you might not even know about? Well, we wanted to do something really important. We wanted to create the absolute best way for developers to experience and learn what Red Hat has to offer for free. Now, you might be saying, well, Red Hat's open source, I can just download stuff for free. Yes, but do you really want to try to run OpenShift? Okay, OpenShift local exists, but it will completely, cause your laptop to launch into space. And running a proper OpenShift cluster is really difficult, not to mention getting Ansible online and everything. And we heard this time and time again that people said, look, you're open source, that's great and all, but how do I actually use this stuff? I want to learn how to use this capabilities, and I want to actually experience it. And then on the flip side, which is what we'll talk about today, how do you enable this kind of capabilities and how does it actually work? And ultimately, what you wind up with is a system that's kind of a mouthful, and I'm going to tell you today the architecture behind it and what it does. It's a self-service, multi-tenant cloud development environment for developers that runs Red Hat technologies powered by OpenShift. Good God, I need to fix that. Basically, how do we enable a world where a developer can instantly sign in and have access to every technology available in their own world, but it's safe and it's cost effective and it won't blow up and it's constantly scalable and it's fixable, but also it's not going to cost so much money that executives get upset. And that was a big challenge. But first, raise your hand. Who here knows what OpenShift is? Okay, good. There's enough of you that it justifies my slides. All right. So really quickly, for those that don't know what OpenShift is and what Red Hat's ecosystem are, let's kind of look at it. So you have the Developer Sandbox here. That's the thing I'm talking about today. It's a place for you to experience everything that Red Hat has to offer. Those things are OpenShift, data science, dev spaces, API, Ansible, RHEL, and more. These are the technologies that Red Hat has been building and contributing to. RHEL, Linux, Ansible, OpenShift, Kubernetes. Dev spaces is Eclipse. It's Eclipse Foundation stuff for VS Code. Data science is actually a cacophony of AI capabilities and stuff. And then API management, I forgot what that's built on. But all of this together enables you to kind of have this holistic view from a Red Hat perspective. And OpenShift's what powers it. And OpenShift, if you don't know, it's basically a enterprise-capable Kubernetes environment. Where we are really popular and known is if you want to run things on actual bare metal servers, or you want to run things in the cloud, but you don't want to be tied down to a service. And so what differentiates OpenShift from Kubernetes is, well, it's still just Kubernetes, but it's a lot of batteries included. And this is why developers kept coming to us and asking, hey, I really want to use OpenShift. I want to learn best practices for managing metrics and image build tools and an image registry. And I want to understand how to deploy things securely with just not, vanilla. But what always kind of came in the way is that's a lot of extra stuff to configure yourself with Kubernetes. And so OpenShift does it for you, but running OpenShift is very difficult. Now, I really want to quickly, and we can go into this later on afterwards, talk about really what makes up OpenShift, just so you know. So that is what OpenShift is. The blue is where Kubernetes is. The green is OpenShift. So OpenShift adds a lot of stuff on top of what is Kubernetes. And I hope you're starting to see, wow, okay, that's a lot to run. And now I can see why developers have a hard time using this thing and deploying it. So then if that's what all this stuff is, what actually do you get when you use Developer Sandbox? What is the stuff that developers asked for? Well, you get a 30-day OpenShift cluster that's all yours for 30 days for free. You can run up to 14 gigs of memory and 40 gigs of storage in as many pods as you'd like. They can run for 12 hours and then they auto spin down. And if you want to have fun, you can make a cron job that spins them right back up, or you can use serverless and they'll just wake up on their own. And you have a suite of the biggest technologies that are available right now. Let it be Tecton, let it be the web terminal that lets you actually access these servers underlying the system, and quite a lot more. So Developer Sandbox, right? It lets you get access for free immediately to Red Hat's technologies. Right. Now for the really exciting part. How does this actually work? How do we enable this? We created OpenShift as a service. Who here remembers OpenShift Online? Shoot, I was hoping no one would remember that. Okay, so OpenShift Online was something that Red Hat worked on a while ago, and the idea was exactly this. How can we make OpenShift to be a single-click service? Red Hat then realized that that actually didn't make any sense to do, but the experiment was a great idea. The team that I worked with realized, wait a minute, what if that became for developers? What if they could literally click a button and have everything that they need that is based on those open source technologies? They don't have to sign up for a cloud provider, they don't have to provide a credit card, and they get the truly enterprise system. So that's what this became. But then the question goes, well, how do you actually achieve this kind of capability? Because you can't just do multi-cluster. If you want to enable people to have access to a developer environment, you can't simply just have multiple clusters. Because the developer can't be allowed to know what's really happening under the hood. When you use AWS or Google Cloud or Azure, do you actually know what's going on underneath them? No, you don't. It's abstracted for you. That's the whole point of the cloud. So we needed the same capabilities, and OpenShift isn't designed for that. So we're going to need to figure that out. The next one is those user applications, they're going to need to be firewalled because they're all in the system. Normally, OpenShift does firewall them, and Kubernetes does firewall them, but Kubernetes was designed that the developer doesn't need to necessarily be completely firewalled. Yeah, you can set up permissions, but not proper firewalling. It's assuming that you're all part of the same company. But in a sandbox environment, that isn't the assumption. Next, you needed to be able to constantly add and remove clusters, because we can't have one cluster that's handling tens of thousands of users with God only knows how many pods. We can, it is possible, but scaling starts to get strange and cost becomes a problem. And that last one is cost sensitive. Since the goal is let's make this thing free, let's make this available for the developers, well, we don't want this thing to become a burden to actually run. So how do we enable this environment that isn't simply just a multi-cluster problem? How do we enable developers to have everything abstracted away? It kind of comes down to two approaches. The first one, and when I said it's not just a multi-cluster problem, I saw some people kind of like look up multi-cluster or a private cluster. Well, what if we just gave everybody a private cluster? Well, that's got some good and bad. Good, the user can experience all OpenShift, and then inevitably all the stuff OpenShift runs. You can get Ansible, VMs, everything, right? You can install any operators. So now you can make it do whatever you like. But that also means that the users can be exposed to the admin system and cause the cluster to become unstable and collapse. It also becomes incredibly slow to spin up and spin down because spinning up all the different components necessary takes a while. And spinning them down takes a while. And lastly, oh boy, is that expensive. If you have to, remember those boxes I showed? All those crazy boxes? Every developer has to spin up all of those boxes duplicatively every single time. That's insanely expensive. So, what's the other option? What if we treated namespaces as clusters? So, okay, great. That's much cheaper. Adding and removing namespaces from a Kubernetes environment or OpenShift is pretty trivial. It's very, very fast. Cluster stability is taken care of by the cluster itself, and it's extremely cost effective. Cons, very complex to manage that. Because remember, we have to abstract the entire system from the users. So if we just use namespaces, how's that going to work in a multi-cluster environment? Because everyone needs to see the same thing. So if I'm in one cluster and another person's in another cluster, they need to be exactly the same. They need to have the same operators, same capabilities. And that means we somehow need to synchronize all of the clusters. And they can't really learn the OpenShift admin experience, and we can live with that. So we went with the private namespace. And what was a little different with the private namespace, we quickly realized early on, is there isn't really a system at the time, this was 2020, that really could handle this the way it was needed. So we had to build it ourselves. What did we come up with? Well, we got 3 clusters here. We created the concept of a control cluster. We essentially created a meta Kubernetes. So you have at least 2 OpenShift clusters. Generally, we have more. I think right now, today, we're running 5. We spun up an extra one just for this event to make sure there's room in the system, but it'll spin up more if it needs it. The control cluster takes care of what we call the registration service. So this is the self-service multi-tenant manager. So what this does is it allows any of you to instantly go online and request an account. And within about 2 seconds, the system has you ready to go. It's added you to the identity provider, and it's gotten everything set up and running. But the registration service just creates you and assigns you to a cluster, because you will not live in the cluster, the control cluster. You're going to live in one of the member clusters. Each member cluster is similar to a worker or a node in Kubernetes, except it is Kubernetes itself. To manage this, we have what's called the host operator. Wherever the host operator lives, that is the control cluster. The registration service technically can run on member clusters, but we always run it on a control cluster for reliability. And the host operator has member operators. And each system that can allow users to actually run and use and deploy applications and protect them has to have a member operator. So in this architecture, the control cluster has a member operator. We used to do that. We don't do that anymore just because of scalability. And then the host operator talks to these member operators and instructs them. So for an example, today during the demo, you guys are all that have computers are going to, well, maybe set up an account in Developer Sandbox. Should take you no more than about 1 minute. And when that happens, all of you guys, as you start to show up, will land at the registration service, and then the host operator will then figure out what to do with you and then send you to the member operator. From your perspective, you just instantly showed up in an OpenShift cluster. You have no idea what actually happened. And even though some of you will be in one member cluster and another one will be in another member cluster, you will have the exact same perspectives. The services provided, the capabilities, everything is exactly the same. And it's made perfectly homogeneous. So as operators are installed, the host controller and member operator will take care of propagating the installation to make sure that they're fully replicated. And then lastly is the actual application operators. So these are things like your GitOps operator that we have that allows you to do Argo CD and Tecton pipelines. The actual host and member operators do the installation of this and maintain it, so that if a configuration is changed in one application operator, it's copied across all the clusters so that everyone has the same experience and things don't get out of sync. So when you sign up, what's different between normal straight up Kubernetes is we had to create a whole cloud authentication service. Just like when you sign in to AWS, Google Cloud, Azure, IBM Cloud, you're signing into a provider, going into a console to get access to the resource. That doesn't exist really for OpenShift, because OpenShift's assuming that it's just for one, group of people. So we had to create that concept. And what we ended up doing was integrating with Keycloak, Red Hat's open source SSO provider, so that when you show up and you authenticate, you just simply use your Red Hat account. So a Red Hat account, if you use any Red Hat's developer resources, if you download any of Red Hat's content, if you do anything with Red Hat, you have a Red Hat account. That Red Hat account is now associated with Developer Sandbox so that you simply just click a button, sign in with your Red Hat account, and that actually takes care of provisioning it. And it does all of this through that registration service and the host cluster. So this is the initialization phase. Next up is this crazy thing. I didn't draw this. My engineers did. And by the way, I didn't build this. I'm the PM. All credit goes to the engineers that I work with. They're absolutely brilliant. All of this is open source, by the way, so you guys are free to use it to replicate this exact same capability yourself. Nevertheless, so let's kind of walk through this at a real high level. So you have your host cluster and member cluster. We have the person that comes in. That person comes in, registration service takes care of them, and then it sends them into the member cluster. But what makes this different than just what's normally been done, and why all this is cool, this is just using off-the-shelf components already in OpenShift. There is very little custom code that's actually written to do this. Most of this is leveraging the automation capabilities of Tekton and others to create this experience. We wanted to design it so that this demonstrates the flexibility of OpenShift and Kubernetes itself and how all of those different services, let it be etcd and the API servers, work. So you'll notice that host operator, it just talks to the API server, the generic one that's built inside of Kubernetes. From there, it's able to actually set up, automatically deploy the user, set up their permissions correctly, and get them access to the technology that's already there. So when you sign in and go to dev spaces, which creates an entire developer portal, you're automatically spun up and ready to go. And all of this is managed by different capabilities and teams. So this is something that Red Hat is constantly scaling up. So we're going to be deploying the Ansible automation platform for free and Backstage IO inside of here soon. So any developer can go in and experiment with that. The reason all this works is it's leveraging the existing capabilities, which means we're running on OpenShift Dedicated in AWS. Well, that means the OpenShift Dedicated SRE team makes sure the clusters are all running, because as far as they're concerned, they're just clusters. We didn't want them to be special. Next, the Sandbox team, me and my team, we make sure those member host operators are all working correctly. The actual capabilities developer tools, those are just the off-the-shelf tools you can download. And so that means it doesn't matter what you're actually trying to do, the system will happily support anything. When you add those operators in, the member operator and host operator takes care of controlling them all across. And then lastly, the developers.redhat.com, that's the site that actually runs and kicks off the registration service. So we wanted to make this so that anybody could replicate this architecture if they like. Let it be for their own company or just to show and demonstrate the capabilities of a truly self-service Kubernetes environment. Now, we do plan to make some changes to this to use Kubernetes' newer capabilities that are coming down the pipeline. So specifically how it handles hierarchical namespaces and things like that. But right now, we're not really using that. Okay, so that was me talking a lot. Now let's actually do something together. So my team is freaking out right now because I told them that I'm going to tell everyone here to do stuff and follow along live, and they are sweating bullets because they don't like that. Anyways, so let's go ahead and do this. So I'm going to go ahead and click into Sandbox here, and I'm going to go ahead and sign in and get started. So to start your Sandbox for free, like I said, there's your Red Hat account. So I'm just going to sign into my Red Hat account. Hit go, next, log in. Great. If you have a Red Hat account, this is what you'll see next. Fun thing I want to tell you about this under the hood. We're using reCAPTCHA here because how many of you immediately see the problem with allowing anybody to sign up for free OpenShift? Yeah, the Bitcoin miners found us, and that was fun. Now we have a lot of capabilities under the hood that monitor all the processes in real time and will spin down pods and entire accounts automatically if it detects malicious behavior. I was told I can't share you how that works, and I'm really upset about that because I wanted to. But what I can tell you is that we use reCAPTCHA for verification because we used to use phone numbers, and that also didn't work very well. because if you were in other countries, it just didn't show up. Okay, so let's go right inside of my sandbox. So now that I've clicked starting your sandbox, and just like that, everything's ready to go. So in that one click, the registration service associated me back to the SSO system, contacted the host operator, spun up my namespace, and deployed all the applications that need to be in the namespace, sent the redirect back to the registration service so that I could go to the correct page, which is actually the OpenShift dedicated environment, and had everything ready to go. So the whole environment is ready. When we did this with just individual cluster spin-ups, the average time was about 5 to 10 minutes. This, as you can see, is about 3 seconds. When I click login with Dev Sandbox, it'll take me here, and welcome. We even have these nice little onboarding guides. What's really special also about this is because we are running this OpenShift environment, we were able to build a lot of capabilities in that is not normally available in an OpenShift environment. So that includes the ability for in-app help and laboratories and getting started material. And that can all be found here in this little question box. You can go in, see how-to articles, such as exporting your applications to Rosa, OpenShift cheat sheet, and more. And so what this became internally and now externally is an entire way for you to experience everything, let it be as a person at Red Hat learning, or let it be somebody outside. So in this case, the last thing I was playing with is I had deployed Backstage and was keying around with the Backstage developer portal. Now, the last thing I wanted to kind of show is if we go over here, let's go ahead and just do a sample really fast to kind of show how quick this works. Let's do Go. Go is my favorite programming language. At least right now it is. Let's see how that goes. And create. And so now what we've done is the system has taken this example from Go. It's been able to pull that in and start automatically deploying it using Tecton. You notice I didn't have to do anything. And that's because the Developer Sandbox, we have a ton of stuff ready to go out of the box. We built these different tools with the OpenShift team to enable you to very quickly be able to access this. Again, all of it's open source. You can run it yourself. Now, you'll also notice that that Go application is taking a little bit longer to wake up. That's because we have a sleeping system to improve system efficiency. So what happens is when an account doesn't have anything running and no pods are running, everything goes into like a deep sleep state. Once those kind of kick up and catch up, then everything starts to wake up. And the first time it's a little bit slow. If you use Knative, so like serverless, it runs a lot faster. Yep, this is what they feared. Okay, so we're going to pretend that that's working, and we're going to move on to the next thing. So the last thing I wanted to mention really quickly was that everything you just see there, it's fully available to everybody here for free forever. So you get 30 days of system stability, and then what happens is everything erases itself and cleans it out. The reason that we do that is that's to manage resources. We found that a lot of people would turn on their accounts and leave it. And even if they were active, they were hogging up resources. So what we do is every 30 days, your entire sandbox erases itself. To save your work, we built an export function right here. And so what that does is it takes everything you've done in the Developer Sandbox, compiles it into one giant zip file full of YAMLs. And when you turn on your sandbox again, you just feed it the YAMLs and everything will wake right back up. Oh, there it goes. So now I have my Go application running. Well, it's still waking up. That's fine. And this means that you can constantly use this for any of your development. We have a lot of teams that use this in-house for when they're testing out new concepts and ideas, or when we're wanting to learn more complex network configurations of Kubernetes and OpenShift environments. And lastly, we focused heavily on the onboarding experience. So what you didn't see on the startup is we have a complete onboarding experience that show you the different features that we have in the system. Every single thing are individual components from our GitHub repo that actually kind of walks you through how all this can be used. So we've got a couple components, our service operator and everything else that you can use yourself. And then the one last part of all of this is Dev Spaces. And so with Dev Spaces, we now have a completely integrated development environment. Oh, please work. Oh, okay. Well, that's fine. What DevSpaces does is it gives you a VS Code IDE running in your sandbox that allows you to completely build and develop your applications within a single click. When I'm not running on the dev servers, I guess. And it enables you to very easily work with the application that you have and be able to rapidly deploy it back without having to install anything on your laptop. So common use case we have for that is my laptop's not as strong as it needs to be, so I wind up using DevSpaces. All right, so what I wanted to do now, let me actually flip over to the presentation, is a Q&A session. This is a big room, and so I figured this might be helpful. So if you go to that URL there, you can type in questions and I can try to answer them. Or you can just shout, I guess, and I'll try to answer them the best I can. So, any questions? Okay, sure. Oh, yes, yes. So, right, to access that, see this little terminal button up there? Boop. Click that and hit start. And now this is going to turn on the OpenShift command line terminal, which in the browser, that gives you the ability to actually manipulate what's going on under the hood with the OpenShift server. We have it permissions set and controlled like everything else. So what that means is you don't need to worry about running a command that could possibly destroy the cluster or your namespace. And if you ever destroy the namespace, there's a button up there for help. That's what the little bubbles are. And we will actually force reset your namespace and give you a new clean environment to get started on. There it goes. And so now you have a full terminal ready to go. Help, run all the cans you want. Helm, Knative, Technon, whatever you would like is all there. You can deploy whatever you would like. Again, assuming 14 gig memory limit, but like if you're deploying something that takes that much, like it's weird. I don't know what takes that much. Any other questions? I saw a hand earlier. Yeah. Yeah. Yes. Okay, so he was asking about vCluster and crossplane, right? Yes. So we did look at both of those and we experimented. The problem was that where we're taking this is all of Red Hat. That includes virtual machines. vCluster and everything else doesn't super play well when you need to handle virtual machines, because we're working so that you can actually have RHEL VMs fully running in here. Click on a button and the entire RHEL UI opens up. And now you can go in and see your RHEL VMs and write Ansible automation all inside of your sandbox to orchestrate your RHEL VMs. So we originally had experimented, but we realized that would not let us get to where we want to go. We open sourced all of this so that potentially other organizations can leverage the same capabilities. Did that answer your question? Okay. Yes. Yes. The challenge that we're working on is, as you can imagine, letting anybody just run the RHEL VM in here can quickly get out of control. And so we're working on integrating it so that when you deploy the RHEL VM, first off, you don't have to worry about licensing. It'll automatically use the credentials for the account that you're using to get the developer licensing, which is 16 VMs, 16 RHEL licenses per person for free. It'll automatically use those. And then on top of that, it will automatically deploy a special permission set that will prevent you from running Bitcoin miners and things like that. 100%. So what I was just saying is this is a perfect place for you to practice your Red Hat Ansible skills. That is exactly what this is designed for. So if you wanted to learn how to actually say, hey, I want to deploy 5 servers here, that is cut off. I cannot see that. Fine. And I want to see how they deploy. This would be the place for you to do that. Any other questions? Anybody asking me here? Oh, okay. I never used that feature, and I don't think anybody ever will. Yeah, exactly. All right. If there's no more questions, let me go back here. The last slide. So, yes. Yes. Yeah, great question. So, question was leveraging your already existing GitHub accounts. Great. Yeah, I'll show you real quick how to do that. So, what we do is when you go to add, I really wish this screen was not cut off. Did I hit it? Nope. How about there? Nope. Your screen is like zoomed wrong down here. It's like I can't see it now. There we go. Okay. I can't see that super well. All right, great. So the way that you can do that is you see this import Git. So here you can paste your Git repo, and OpenShift will attempt to automatically detect what kind of deployment that is. And if it doesn't, it'll recommend different ways to deploy things. And then you can pull in your own Git code and kick things off right away. You can also set up the same thing with pipelines. So you can create your own Tecton pipeline in here so that you can have your Git code automatically pushed to your sandbox whenever you make a change. We have examples on all of that on developers.redhat.com. So we have plenty of labs that'll walk you through exactly how to do that. We cover Java, Node.js, Python, Golang. I think we're going to do one in Rust soon. Maybe. But yes. Any other questions? No? Okay, well, thank you all very much. And if you have any further information you want to know about this, I will be down at the Red Hat booth for the rest of this afternoon. I can answer any questions you have about Red Hat's developer technologies and what we are working on next. And also, I'm happy to share with you guys our slides. I will be trying to put all of this up on the Red Hat's developer tools Git repo and the slides. And then you can also find all the source code for everything that we're doing here. Thank y'all very much.